Have you ever wondered how computers do millions of calculations before you can even blink? Or how AI models, scientific simulations, financial predictions all run faster than the human brain can think? Well, what if I told you that behind almost every powerful data science or machine learning task, there's a silent superhero working nonstop? Welcome back to Ruby Parker, where learning meets the future. Today we are going deep, and I mean really deep, into the engine that powers Python's smartest abilities. This is the world of NumPy. Now, before you click away thinking this is just another boring Python library, stop. Because if you understand NumPy, you unlock the real superpower behind AI, machine learning, robotics, physics simulations, and even the Instagram filters you use every single day. Seriously, the moment you understand NumPy, you unlock a doorway into the world of high-speed computation. And trust me, this is a doorway most people never walk through. So let's open it right now. Imagine you're solving a math problem, but instead of solving one equation, you solve 100,000 equations in the same amount of time. Sounds impossible, right? Not for NumPy. NumPy is like Python on steroids. It's a library that lets Python handle huge amounts of numerical data insanely fast. And when I say fast, I mean leave everything else in the dust fast. Think of regular Python as a bicycle, and think of NumPy as a rocket engine. They both move forward, but one takes you to the moon. Okay, picture this. You have to analyze a million numbers. Using normal Python lists, it feels like you're walking with bricks tied to your legs. Slow, painful, and unnecessarily complicated. But with NumPy, it feels like you're flying. Your computer suddenly becomes a math wizard. It crunches numbers with unbelievable speed. And that's why every data scientist, every ML engineer, every AI researcher starts their journey with NumPy. Without NumPy, modern AI would slow down like a snail climbing a mountain. Now here's where things get interesting. NumPy's real superpower is something called an array. And no, it's not just a fancy list. NumPy arrays are stored in memory like neat little soldiers, standing in a perfect line, ready for action. This makes operations incredibly fast. Meanwhile, Python lists, they store data like a messy room, items scattered everywhere. And you know what happens when your room is messy, right? Everything takes longer to find. But NumPy arrays keep everything organized, compact, and optimized. That's why they are lightning fast. Here's a crazy reveal. A calculation that takes 1 full second with Python lists can take 0.01 seconds with NumPy. That's 100 times faster. Imagine shaving hours off your code just by switching to NumPy. You want to know the real reason NumPy is so fast? All right, mini reveal coming in 3, 2, 1. Because NumPy is not actually written in Python. Yep, surprise! It's written in C. A low-level, super powerful language much closer to machine code. That means NumPy runs almost as fast as pure C programs, while still being easy to use like Python. Basically, NumPy gives you C-level speed with Python-level simplicity. It's like getting Ferrari speed with scooter effort. Ever wondered how your smartphone processes images? Every picture, every filter, every effect is nothing but thousands of numbers arranged in grids. And guess what handles those grids? NumPy. When you brighten an image, you're literally adding numbers. When you blur it, you're averaging numbers. When you sharpen it, you're adjusting numbers. Behind every effect you apply on Instagram or Snapchat, there's NumPy-style array math happening in milliseconds. You've heard of machine learning, neural networks, deep learning. Well, here's the truth almost nobody tells you. Machine learning is basically fancy matrix math. And what's the best tool for matrix math? You guessed it, NumPy. Every ML algorithm, from linear regression to neural networks, is built on operations like dot products, vector multiplication, and matrix transformations. And guess who does all of this flawlessly? NumPy. It's the backbone, the skeleton, the engine. Without NumPy, ML models would crawl like turtles. Let me show you how dramatic the difference is. Want to add 10 to every number in a list? In normal Python, you have to loop through each number one by one. But in NumPy, one command. Boom. Done. 10 times faster. It's like comparing someone who handwrites 1,000 envelopes to someone who clicks print all. That's the power of vectorization, doing bulk operations at once. If you peek into fields like astronomy, physics, climate modeling, neuroscience, guess what you'll find? NumPy. Scientists don't use it because it's popular. They use it because it's precise, reliable, and unbelievably fast. You can simulate a galaxy, predict earthquakes, analyze DNA sequences, all using NumPy arrays and numerical computations. And that just blows my mind. Here's another surprise. Most deep learning frameworks like TensorFlow and PyTorch were inspired by NumPy. In fact, PyTorch tensors behave almost exactly like NumPy arrays, just with GPU support. NumPy laid the foundation for the entire AI revolution. If Python is the heart of AI, NumPy is the heartbeat. Did you know NumPy was originally called numeric back in the 90s? Then another library called numArray came along. And finally, both merged into what we now call NumPy. So technically, NumPy is older than many of its users. Think about Netflix recommending shows. Behind the scenes, massive matrices store your viewing patterns. Similarity calculations, predictions, probabilities, they all depend on linear algebra. And linear algebra runs best using NumPy's fast matrix operations. So the reason Netflix knows you better than your friends is partly because of NumPy. Self-driving cars capture millions of data points per second. Radar, LiDAR, cameras, sensors. All that data must be processed instantly. And how do you process huge chunks of numbers that fast? NumPy arrays? That's why without NumPy-style computation, self-driving cars wouldn't exist. Imagine a world without NumPy. AI slows down, data science collapses. Machine learning models take hours instead of minutes. Image processing becomes painfully slow. It would feel like going back to the Stone Age of computing. Sounds dramatic? Because it is dramatic. NumPy is literally the unsung hero of modern technology. Here's something most people get wrong. They jump directly into machine learning without learning NumPy. And then they get stuck. Again and again. NumPy is not extra. NumPy is not optional. NumPy is the foundation. If you understand NumPy deeply, every other technology becomes easier. Pandas, SciPy, Matplotlib, TensorFlow, scikit-learn. All of them speak the NumPy language. Short answer? NumPy can do everything related to numerical computing. Long answer? NumPy can manipulate arrays, reshape data, do statistical analysis, linear algebra, Fourier transforms, random number generation, fast math operations, and even memory optimization. It is the Swiss Army knife of Python. Watch this. In Python, if you have to multiply two lists element by element, it's a headache. But in NumPy, you write array 1 times array 2, and boom, every element multiplies instantly. It's so satisfying you'll want to do it again and again. NumPy didn't just make Python fast, it made Python the #1 language for data science. Before NumPy, Python was too slow for heavy math. After NumPy, the entire world changed. AI researchers adopted it, companies adopted it, entire industries adopted it. And today, NumPy is used everywhere. Google, NASA, Netflix, Tesla, Facebook, MIT, Stanford, and even your smartphone. NumPy is the silent engine behind the digital revolution. Students learning data science today are actually learning the same tools used by billion-dollar companies. And that's empowering. With just NumPy, a laptop, and curiosity, anyone can start exploring AI. It's like having a mini supercomputer inside your code, and that is NumPy. A library so simple, yet so powerful, that it transformed Python into the backbone of modern technology. If you understand NumPy, you understand the heartbeat of AI. You understand the language of data, and you unlock a future filled with endless possibilities. So if you enjoyed this deep, exciting journey into the world of NumPy, smash that like button, drop a comment saying I want more, and don't forget to subscribe to Ruby Parker, where learning meets the future. Because trust me, the future is bright, the future is powerful, and the future is yours, as long as you keep learning. Thanks for watching, and I'll see you in the next mind-blowing video.